Forget the EV hype. While the world argued about batteries, a quiet revolution was brewing in American garages, and it's far wilder than you think. We're talking about real working engines that shattered the rules of a century-old machine. An engine with no cylinder heads or valves, one that tossed out the crankshaft entirely, and a humble Detroit four-cylinder that propelled a family sedan an astonishing 106 miles on a single gallon of gas. These aren't whiteboard dreams. They've been bolted into real cars, tested by the US government, and even sold to the public by the hundreds of thousands. This is the countdown of 8 mind-bending American breakthroughs, from a Silicon Valley company that achieved it all with just software, to an engine that ran on vodka, and a world record set in 2026 that made every engineer in Detroit sit up. The final entry is the most heartbreaking. The only machine on this list to hit that 106 MPG figure for federal testers, only to be quietly murdered by the very company that built it. Number 8 is Dynamic Skip Fire from Tula Technology. Let us start with the strangest kind of breakthrough there is. One you cannot photograph. Tula Technology is based in San Jose, California, and the company did not build a new engine at all. It rewrote the instructions the engine already follows. General Motors licensed it and calls it Dynamic Fuel Management. Here's the problem it solves. When you drive a large V8 pickup down a flat road at cruising speed, you're asking that engine for a tiny fraction of what it can do. All 8 cylinders keep firing anyway, burning fuel to make power nobody requested. Older systems tried to fix this by shutting off the same 4 cylinders every time, like turning off half the lights in a house and leaving them off. Tula went much further. Think of a drummer who does not simply play softer, but chooses individually which beats to strike and which to skip, thousands of times per minute, so the rhythm still sounds even. That is what this software does. It decides for every single cylinder on every single revolution whether to fire it or skip it. The engine can effectively run on any number of cylinders between 1 and 8, changing that decision hundreds of times a second. The claimed fuel saving reaches up to 15%, and this is not laboratory theory. The technology entered production in 2018, and the 1 millionth vehicle carrying it rolled off the line in November of 2020. It is in the Cadillac Escalade, the Chevrolet Silverado, the Chevrolet Suburban, the GMC Sierra, and the GMC Yukon. There is no separate price tag because it is licensed to the automaker and baked into the vehicle you already buy. Now there is a catch, and it is a real one. This makes a wasteful engine less wasteful. It does not change the fundamental physics of how that engine burns fuel. For that, you have to tear the engine apart and start over, which is exactly what a small team in Connecticut did. Number 7 is the X engine from Liquid Piston. If the last breakthrough was pure software, this one goes in the opposite direction entirely. Liquid Piston is based in Bloomfield, Connecticut, and it was founded in 2004 by a father and son, Nikolai and Alexander Shkolnik. After their engine concept placed second in a business competition at the Massachusetts Institute of Technology, their idea was to take the rotary engine, the design Mazda made famous, and turn it inside out. In a traditional rotary, a triangular rotor spins inside a curved housing. Liquid Piston reversed the geometry completely. Their rotor is shaped like a figure 8, and it moves inside a triangular housing. And crucially, the seals sit on the stationary housing rather than on the spinning part. Number 6 is the opposed piston engine from Achates Power. Now we get to the machine that genuinely made engineers stop and stare. Achates Power sits in San Diego, California, and it was founded in 2004 by the late Walmart heir John Walton and the late physicist James Lemke. Their idea was to revive an architecture that engineers had abandoned back in the 1930s. Here's how it works, and it is beautifully simple. In a normal engine, each cylinder has one piston, a heavy cylinder head on top, and a valve train full of camshafts, springs, and valves. In this engine, each cylinder holds 2 pistons facing each other, nose to nose. Fuel burns in the space between them and shoves both pistons apart at once, turning 2 separate crankshafts at either end. Number 5 is the 55% Super Truck engine from Cummins. Let us talk about the single most important number in this entire field: brake thermal efficiency. It measures how much of the energy in your fuel actually becomes motion at the wheels. To put that in perspective, a typical gasoline engine in a passenger car converts somewhere around a quarter to a third of the fuel you buy into forward movement. Everything else leaves as heat through the radiator and out of the tailpipe. Every time you fill your tank, most of that money becomes warm air. The best heavy-duty diesels sit around 43%. In 2010, the United States Department of Energy launched a program called Super Truck, and Cummins, headquartered in Columbus, Indiana, joined it from the beginning. In January of 2021, on a cold night in a test cell, the Cummins team reached 55% brake thermal efficiency from a diesel engine paired with a waste heat recovery system, and the Department of Energy formally recognized the achievement later that year. Number 4 is the linear generator from Mainspring Energy. This one breaks the mental picture of an engine completely. Mainspring Energy was founded in 2010 in Menlo Park, California, by 3 Stanford engineers, and their machine has no crankshaft, no connecting rods, and no spinning parts in the power path whatsoever. Instead, 2 oscillators tipped with magnets are driven back and forth in a straight line by a low-temperature flameless chemical reaction. And as those magnets rush past coils of wire, they generate electricity directly. There is no rotation to convert. There is no gearbox. Picture a piston that never turns a wheel, only slides between 2 magnetic springs, making current on every pass. Because the reaction happens at low temperature and without a flame, the machine produces almost no nitrogen oxides and no particulate matter, which is why these units can be permitted and installed in places a conventional generator never could. Before we get to the podium, it is worth stopping to ask why all of this is happening now, in this decade, rather than 40 years ago. The answer is a paradox that trapped engineers for a century. To make an engine more efficient, you squeeze the fuel and air harder before you burn it. But squeeze too hard, and the mixture explodes early and violently, hammering the engine apart. That last idea is the whole ballgame. And in April of 2026, the pressure to act on it became public when the Chinese automaker Geely certified a thermal efficiency of 48.41% for a hybrid engine, and had Guinness World Records verify a test run returning 2.22 L per 100 kilometers in an M Grand sedan. A figure that works out to roughly 106 miles per gallon, achieved mostly in highway conditions. For comparison, Toyota's Prius managed 92.9 miles per gallon on its own efficiency run. That certified number is where the figure 106 entered headlines all over the world. It was a controlled run, not everyday driving. And it deserves that caveat, but here is the part that got completely lost in the noise. An American car earned that exact same number from federal testers more than 10 years ago, and Detroit walked away from it. Number 3 is the harvester system from Scout Motors. Now the story shifts from laboratories to factories and buyers. Scout Motors is building a plant in Blythewood, South Carolina to produce 2 vehicles, the Traveler Sport Utility and the Terra pickup. The engineering choice they made tells you where the industry is going. Their harvester system pairs a battery pack of roughly 60 to 70 kWh with a gasoline engine that never touches the wheels. The engine exists purely to make electricity. The battery alone delivers around 150 mi of driving, which is about 241 kilometers, and once the engine begins generating, total range climbs past 500 km or roughly 805 km. Number 2 is the Ram 1500 Ram. This is the machine that turns the idea into steel on a dealer lot. Originally shown as the Ramcharger, now badged the Ram 1500 Ram. It appeared in production-ready form at the 2026 Detroit Auto Show and is scheduled to enter production at the Sterling Heights Assembly Plant in Michigan in the second half of this year as a 2027 model. The architecture is the same principle executed at full size. A 92 kWh battery sits between the frame rails, feeding a 250 kWh drive unit at the front and a 248 kWh unit at the rear, for a combined 647 horsepower and 610 lb-ft of torque, which is about 827 Newton-meters. Number 1 is the Chevrolet Volt and the Volt X system from General Motors. Here is the payoff, and it is the machine teased at the very start of this video. The second-generation Chevrolet Volt was rated by the United States Environmental Protection Agency at 106 mpg per gallon equivalent combined. Not a press release, not a company claim. A federal rating on a window sticker in a Chevrolet showroom, and it happened a decade ago. The architecture was the one every automaker is now scrambling to copy. 8 engines, software that skips heartbeats, a rotor turned inside out, a cylinder with 2 pistons and no head, a diesel that drinks its own exhaust heat, a generator with no crankshaft, and 3 vehicles built around the idea that an engine should stop driving wheels and start making current. Every one of them is American, and every one of them says the same thing. The engine is not finished. It is being rebuilt from the inside out. And the machines that come out of this decade will burn a fraction of what your current car burns. The question is no longer whether the 100 mile per gallon family vehicle arrives. The question is how soon and which badge is on the hood when it does. If you enjoyed this, hit the like button, subscribe, and turn on notifications so you never miss the next one. There are related videos on the screen right now if you want to keep watching. So, here's a question for you. Do you think Detroit made the right call killing the Volt when it did? Or was it the biggest mistake in modern American engineering? And which of these 8 would you actually want under your own hood? Let me know in the comments.